So this is similar to the last concept check question we just had. If two balls are repelling each other, they must have the same charge. Therefore, 1 and 2 must have the same charge, so they could both be positive or both be negative. But notice 1 and 3 are also repelling each other, so they have the same charge. So they could both be positive and they could both be negative. Well, if 1 and 2 have the same charge and 1 and 3 have the same charge, then 1, 2, and 3 all have the same charge. They could all be positive, they could all be negative. And in this case, these concept check questions, they seem kind of silly. Like, why are we trying to figure out random weird objects, how they're charged? But in real life, I want to point out we use charges to our advantage all the time. Whether it's to get toner to stick to a piece of paper when you're printing your English paper off a laser printer, to making a Xerox copy, to using the latest e-ink readers like the Kindle, Amazon Kindle. Those just use static charges to generate your image or display. Materials can be classified into one of these three categories, and in general, materials that are good conductors are metals. And the idea is, you can think about it, conductors, they let electrons freely move through the material there. The electrons are loosely bound. Things like copper, steel, iron, etc. So a real simple way to prove that is if you touch like the metal leg of a chair in your classroom, or like the metal part of a pot, it feels cool to the touch, and that's because conductors are good at drawing heat and electricity away from your body, even though the metal chair or pot would be the same temperature as what's in the room there. Contrast that with materials such as plastic or wood. These are called insulators, where the electrons are tightly bound. And a lot of times in real life, we'll take conductors like copper wire and we'll wrap them in an insulator like plastic to help transport electrical current safely without presenting any hazards and shocks there. If you think about like a pot, same idea. Your pot will be made out of a conductor like metal, and insulating wooden or plastic can will be used. Some materials are what are called semiconductors, which they can sometimes act as conductors, sometimes act as insulators. And silicon is the best example. You take sand and you go it into a crystal, special way, and then you can sometimes conduct electricity, sometimes not, and basically make microscopic switches, which is how computer chips work. Moving on, we have a big idea called the conservation of charge, which simply states that charge cannot be created nor destroyed. Objects become charged by transferring charges from one object to another. So for example, a classic thing is to generate static charge by rubbing two things together. So classic thing you could do is if you can take something that likes to grab electrons, like a plastic balloon or a plastic rod, and then you rub it against something that likes to lose electrons. Things that are furry, like a cat or a piece of rabbit's fur, or like a fleecy sweater there. And when you do that, the charges get transferred there. So the question is, if you take a plastic rod and you rub it against fur, the rod likes to grab electrons. What happens to the fur? And the answer is the fur also becomes charged. So in other words, if I rub something that's furry and fleecy, like wool or this piece of fur here, it's going to give away electrons. So the plasticky object will grab it. Or like in this little animation here, you'll see the wool likes to give away electrons. The plastic likes to grab it, the plastic PVC pipe there. So notice if it grabs electrons, it becomes negatively charged, and the fur loses electrons, it becomes positively charged. So it looks like we created two charged objects, but we really didn't. We just transferred charges from one object to another. Charge is always conserved, just like mass and energy, momentum, etc. Three main methods of charging something with electrostatics, which would be charging by friction, by contact, and by induction. So let's look at the first simplest one, which people discovered, which is charging by friction. And the basic idea is if you rub two things together, one thing likes to grab electrons and one thing likes to lose it. So electrons move more easily because they're lighter than the protons and they're not locked inside the nucleus. So in this case, you could do something in a lab with a fancy plastic wrap piece of fur, but if you just take a comb, same idea, rub it through your hair, or maybe a classic thing you've tried in the wintertime where you drag your feet across carpet, and usually if it's a really furry, woolly carpet, that works really well. Or in this case, this guy's dragging his rubber-soled shoes across some vinyl floor. And so because his shoes like to give away electrons, the floor likes to grab it, he'll build up a net charge on his body, and then once he reaches out for that metal doorknob, which is a good conductor, it will then try to balance out the charges on his body, and he gets a spark. Get a little shock you might notice sometimes in the wintertime there. So one way scientists can figure out which materials like to lose electrons versus gain them is what's called the triboelectric series. And what this is it's a list of materials that was developed over time, looking at what happens when you rub two things together, or you put them under pressure, and you see which ones tend to give up electrons and which ones tend to grab electrons. So things that are higher up on the triboelectric series, they like to give up electrons, like your human skin, air, fur, glass, wool, etc. And then the things at the bottom, they like to grab electrons, like saran wrap, vinyl, polyester, rubber, etc. And in real life, the other factor that's important is the humidity that's present in the air, how much water or moisture is there. And the reason why is because when there's a lot of moisture in the air, notice if you look at this chart about different ways of generating static charges, like dragging your feet across the carpet, if there's a lot of humidity, a lot of water in the air, the amount of voltage you generate is a lot lower. And that's called atmospheric charge theft, where if you have a charged object here, let's say there's extra electrons here, notice the water molecules, H2O. Water is a polar molecule where the hydrogen and the oxygen, they aren't evenly balanced in charges there, so they like to grab extra charge and take it off an object. So long story short is, if you notice in the wintertime, when it's really dry, the air is dry, the humidity is lower in the air, your skin gets dry and cracked, you need more lotion, that's when you tend to notice static electricity more. When you take off a fleecy jacket, you go to touch the doorknob on your car, etc. So this table you don't have to copy down. You just have to realize we would use something like this to do static electricity experiments. We would usually pick something that's high up on the positive side, like rabbit's fur, and then something that's down low on the negative side, like vinyl plastic, like a PVC pipe. And we would rub these two together to try to generate a static charge to do experiments, see what's going on. And so we'll get to do that throughout this unit.